Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khalid bin Hassan, and in this video we are going to discuss about the recursive variation, which are direct, indirect, tail, non-tail, nested, and excessive. Alright, first of all, we are going to discuss about the direct recursion. Okay, let us go straight to the example. As you can see, this is the example of this is the factorial calculation method. Okay, you can see this the fact is the output and the n is the input. And if the n equals to 0, so the factorial is equal to 1. Everyone know that 0 factorial is equal to 1. So if the n is not 0, so we are going to go to the bottom part. So bottom part is called factorial and n minus 1. Okay, the formula is factorial n multiplied by factorial, then we return. Okay, to make it simple, we are going to put the value. Okay, let's see here. 4 factorial, we are going to put the n is 4, so 4 factorial here. We can see if 4 factorial will be equal to 4 multiplied by 3 factorial. So 3 factorial will be equal to 3 multiplied by 2 factorial. So 2 factorial will be equal to 2 multiplied by 1 factorial. 1 factorial will be equal to 1 multiplied by 0 factorial. So 0 factorial, as we can see, is equal to 1. So 0 factorial equal to 1. Then we trace back 0 factorial, we substitute here to the 1 0 here. Factorial is equal to 1, so we substitute the 1 here. So 1 multiplied by 1, 1 factorial will be equal to 1 multiplied by 1, so we get 1. So the value of 1 factorial we substitute here. So we got 2 multiplied by 1. The 2 factorial is equal to 2 multiplied by 1. So we get 2. So the 2 factorial we substitute, we get 3 multiplied by 2 factorial. So the 2 factorial we got 2. So 3 multiplied by 2, we will get 6. So 3 factorial equal to 6. Then we substitute the 3 factorial into 6. The value of 6. So 4 multiplied by 6 is equal to 24. So the answer for 4 factorial is 24. This is the example of the direct recursive. Next is the indirect recursive. The indirect recursive, as example, the function 1 which has called a function 2, then the function 2 call back the function 1. That is the example of indirect recursion. So it can be a long chain or just 2 like that. Okay, the indirect recursion can occur when there is a chain of calls of the form of f calls the f1 function. So in the f1 function, it called the f2 function. In the f2 function, it called the f3 function. So ultimately, like we can go on into the fn function. Then the fn function, it calls back the f function here. So that is the indirect recursive. Next is the excessive recursion. We take the Fibonacci sequence as example. So we can see here the algorithm. Algorithm Fibonacci. We can let's see the below here first. The n is like this, is the place for the numbers, how many times the place. Then the fib is the Fibonacci series sequence. Okay, we have to see here if the value of n is 0 or 1, where so the fib is the value of n, so fib is equal to 0 or 1. If the value of n is larger than 1 or 0, we have to use this, cos the Fibonacci fib a n minus 1 n minus 2, then cos again fib Fibonacci fib b n minus 1. Then this is the formula, fib a plus fib b, then return. You can see here we have to take the example, the recursion tree for Fibonacci 4. So Fibonacci 4, then where this is the fib a, this fib b. So fib a, you can see here n minus 2, 4 minus 2 is equal to 2, here 2. Then 4 minus 1 is equal to 3. Then the 2 is we have to do the same to n minus 2 is equal to 0. Then the n minus 1 is 2 minus 1 is equal to 1. So we can see here the value of 0. If the value is 0, the Fibonacci value is 0. Then if the value of 1 is also 0, is also going to be 1. Then the 3 here, we can see the 3 minus 2 is equal to 1. Then the 3 here minus 1 is equal to 2. Then lastly we minus the 2 here. 2 minus 2 is equal to 0. Then the 2 minus 1 is equal to 1. The 0 here we get the 0 back. So also for the 1 we get 1 also. Then we plus the value. 1 plus 0 is 1 here. Okay. Then 1 plus 1 we get 2. Then 1 plus 2 we get 3. So for Fibonacci 4 we get 3. We can see here for the Fibonacci, the fourth place, we get the Fibonacci value is 3. That is the example for the excessive recursion. Okay, next is the nested recursion. We have to use the example. We have to use the Ackermann function. Ackermann function is defined as like this. So m plus 1. So if you can see here a, n and m. So if the value of n is 0, we have to m plus 1. So if the n is greater than 0 and m is equal to 0, we have to use this, n minus 1 and 1. So if n and m both greater than 0, we have to use this, n minus 1, and then a, n, m minus 1, like that. Okay, as example we can see here. Now find the a, 1 and 2. So the value of n here is 1 and the value of m here is 2. Okay, you can see here both are greater than 0. So we have we take the last equation. So n minus 1. So n minus 1 is 0. Then a, n is 1. So then m minus 1. The m is 2, so that the 2 minus 1 is equal to 1. So the value of m and n is still greater than 0, so we have to bring it down like this. It's nested like this, then both still greater than 0, we have to take this equation back. So a n minus 1, the value of n is 1, so 1 minus 1 is 0. Then a, then m, then the n is 1, so then the m minus 1, m is 1, so 1 minus 1 is 0. Then we get here a 1 and 0. We can see here the value of n is 1, n is greater than 0, then and the m is 0, so we take the second equation, the a, n minus 1 and 1. So n minus 1, the na here is 1, so 1 minus 1 is 0, then 0, then 1 here, so we get a 0 1. Then we bring here down a 0 1, a 0 1. We can see here the value of n is 0, so we trace back how many times we did that. 4 times, so the value of m is 1, so 1 plus, we have to take this equation because the value of n is 0, so m is 1, so 1 plus 1 is 2. Then we bring down here the 2 is we have done it for 2 times. We have to do it 2 times more, so the 2 plus 1 is 3. So we bring down here a 0 3, m plus 1, m is 3, m plus the 3 is 1, 3 plus 1 is 4. Then we get here 4. The value of a 1 2 is equal to 4. This is the example for the nested recursion. Last one, we are going to talk about the tail and non-tail recursion. So the tail recursion is characterized by the use of only one recursive call at the very end of the method implementation. Okay, in this example, we can see here the tail is called at the end of the program only once. Then we can see at the example of non-tail recursive, you can see it called 2 times. So this is the non-tail recursion. That is the example for the non and tail recursion, non-tail and non-tail recursion.